Hey, welcome to The Explainer. So today we're talking about cannabis, but probably not in the way you're used to. Forget the whole is it good, is it bad debate for a second. The real story, the one science is uncovering, is all about timing, it's about biology, and it's about two totally different brains, the one that's still growing and the one that's starting to age. So, let's dive right in.
I mean, seriously, it feels like it's everywhere now, right? And with that, this question has never been more important. We hear all sorts of conflicting things, from friends, from the news. So what does the science actually say? Well, to get the full picture, we really have to split this story in two. And we're going to start with the brain when it's at its most vulnerable.
You know, the teenage brain it's a massive construction zone. It's furiously wiring itself up, fine-tuning connections, and this whole process goes well into our mid-20s. So when you introduce a powerful substance right in the middle of that critical construction phase, well, that's where the science is pretty much unanimous, and honestly, it's pretty concerning.
And these documented effects, they're really consistent across a ton of major studies. We're talking about real, measurable impacts on how you think, how you remember, even on the actual physical structure of the brain. So this isn't just about feeling a little out of it after you use it, it's about potentially changing the entire blueprint for how that brain develops. And on top of that, it can increase the risk for some serious mental health challenges down the line.
Okay, so you hear this term a lot in the research, white matter integrity. The easiest way to think about white matter is like it's the fiber optic cable system for your brain. It's what lets different parts talk to each other super fast. And what brain scans have found is that in teens who use cannabis, especially heavily, the quality, the integrity of those cables is often lower. And that just means the whole communication network is less efficient, which could explain a lot of the cognitive issues we see. And this really gets to the most critical piece of the puzzle, when you start. It matters a lot. Research from experts like Dr. Stacy Gruber at Harvard hammers this home. The brain before age 16 is doing this massive remodel of the frontal cortex. That's your hub for judgment, for planning, for not doing dumb stuff. Messing with that process can have effects that last a long time, in a way that just isn't seen in people who start using as adults.
So the main takeaway from this first part is that all those warnings we hear about teen use, they're not just talk. They're based on decades of solid research. The THC in cannabis can seriously disrupt the super precise chemical signaling the brain needs to mature the right way, and that can lead to changes in both its structure and how well it works.
For a long time, yeah, that was pretty much the whole story. A story of risk, a story of decline. But you know how it is in science. The story is never really over. And some recent research has uncovered a completely unexpected and frankly kind of baffling other side to this.
So let's flip the script. Instead of looking at brains that are under construction, a bunch of researchers started asking a different question. What happens when cannabis is introduced to a brain that's, well, already fully built, and maybe is now starting that natural process of aging? And this is where it gets really wild. A huge study from CU Anschutz, using a massive data set from the UK Biobank, found the exact opposite of what we see in teens. Get this. In adults aged 40 to 77, more lifetime cannabis use was actually linked to larger brain volumes in key areas, like the hippocampus. And it wasn't just about size. This was also tied to better performance on cognitive tests for learning, memory, and processing speed. Now, it's not a simple silver bullet. One brain region did show lower volume, so the effect is complex. But still, that overall trend, it just turns everything we thought we knew completely on its head. And you can almost hear the surprise in the lead researcher's own words. Dr. Anika Guha basically says, yeah, I was surprised too. It goes against all the default assumptions, because for so long the story has only been about impairment. This new research suggests that in an aging brain, a brain that is naturally losing volume, cannabis might be playing a totally different role.
Okay, so what is going on here? We have a complete paradox. How can one single plant be tied to disrupting development in young people, but maybe helping preserve function in older people? Well, it's not actually a contradiction. It's a clue. It tells us the effect isn't just about the plant, it's about the biological world it's entering.
So to solve this puzzle, we have to zoom way in, down to the molecular level. We need to understand the body's own built-in cannabis system and how the different ingredients inside the plant can act in radically different ways depending on what's going on inside our brains.
Believe it or not, your body has its own cannabinoid system. It's called the endocannabinoid system, or ECS for short. And it's like a master regulator, helping keep all sorts of things in balance: memory, mood, you name it. A really big theory right now is that as we get older, our own natural ECS starts to slow down. It declines. And so the idea is that bringing in cannabinoids from an outside source, like cannabis, might just help top up and restore balance to that aging internal system.
And here's something else that is absolutely critical to remember. You can't just say cannabis. It's not one thing. It's got over 100 active compounds, but the two big ones you always hear about are THC and CBD. THC is what causes the high, and it's the main driver behind that disruption in the developing brain. But then you have CBD. It's not psychoactive, and study after study shows it can have these powerful brain-protecting and anti-inflammatory effects. So the ratio of these two in any given product can completely change how it affects your brain.
So how can these compounds actually protect the brain? Well, researchers think it's a three-pronged attack. First, they can calm down neuroinflammation. That's this chronic, low-level inflammation in the brain that's linked to almost every major brain disease. Second, they act like antioxidants, kind of like rust-proofing for your neurons. And third, they can prevent something called excitotoxicity. That sounds complicated, but it's basically when stressed-out brain cells release way too much of a chemical that ends up overstimulating and killing their neighbors. Cannabinoids can help put the brakes on that whole destructive process.
All right, let's put all the pieces on the table. We have these two completely different stories. We have the brain under construction, and we have the brain that's in a state of natural decline. We have a plant that seems to be able to both disrupt and protect. Putting these two stories together gives us our final, really powerful conclusion.
And here it is, the whole story in one place. What this shows us is that the impact of cannabis is all about context. In a teenage brain, which is trying to set up its delicate chemical balance, outside cannabinoids can be like a bull in a china shop, throwing the whole maturation process off track. But in an aging brain, where that natural cannabinoid system might be fading and inflammation is kicking in, those exact same compounds might act as a stabilizing, even protective force.
So, if you take one thing away from this whole explainer, let it be this. Cannabis is not simply good or bad for your brain. Its effect seems to be a function of where your brain is in its life story. It is a powerful reminder that in biology, timing isn't just one little factor. Sometimes, timing is everything.
And that leaves us with a really big, really tough question. As cannabis just becomes a normal part of our world, this dual personality creates a massive challenge. How do we build policies that fiercely protect young, developing brains while at the same time we're exploring the potential benefits for our aging population? That is the complicated conversation we all need to be having. There are no simple answers, but understanding the science, that's always the best place to start. Thanks for joining us.